Hello everyone. In this session, let's look at understanding what are the different prerequisites that are required for us to conduct before we begin with executing any of the exercises in this module and the following modules. So we are looking at installing Python and have the necessary setup done in your machines before we begin with any of the exercises like I have mentioned. So these are the three different prerequisites that we are supposed to follow. The very first thing is to install Python on your machines. So you can navigate to this particular URL that I have provided, python.org. Specifically navigate to downloads page so that you will be provided with this particular link where you can download the necessary installer file. So once you download the necessary installer file, you run that installer and follow a series of steps in order to install Python in your desired repository or in your desired directory. Okay, it's pretty easy, it's pretty straightforward. If at all you are facing any challenge in actually installing Python, please reach out to us. We're always available to you in handholding you in any of the issues that you face. Okay, but I am not recommending you to install Python by using this approach. You still can go about installing and try and verify it by yourselves, but still I would recommend you to install Python by using an alternate approach that we are going to discuss now. Okay. Before we get into that, we also would need to understand what a package is. We have dealt with what a library is. We have already dealt with what a library is in one of our previous sessions, but we have extensively not looked at it, right? So we have not covered in a greater detail about library as well. But library or package, I'm using these terms interchangeably. So there is a subtle difference between library and package, which we are again going to understand in our subsequent session. But for now, I'm interchangeably using these terms library and package. Okay. So package here, as I mean to say, is a large collection of modules and subpackages. Let's say that whatever package that I have written here is called as package A. This has got a name to it, right? So package underscore A is the name of the package. So package A is nothing but it's a folder or it's a directory. So whatever subpackages that you are finding here are nothing but your subdirectories or subfolders. Whatever modules that you are observing are nothing but your .py files. Your subpackages in turn can have multiple other modules present, which are nothing but your .py files again. So package, as we can understand clearly from this diagram, is large collection of code written by one or more developers or a community or group of developers in order to solve a specific problem. I have provided an example to you in one of our earlier lectures, that is to compute the distances. Computing distances is a specific functionality which I can import from any of the packages that are already existing rather than I writing the code by myself. So instead of writing the code by myself for a specific functionality, we can leverage the predefined or existing functionality that's already available to us in the form of packages. So modules here are nothing but .py files which would comprise of all of these functionalities which are written in terms of classes or methods pertinent to the class or functions as such. You can import this package A by using this statement called import package A. Or you can import a specific module. Let's say that I'm calling this as module 1, module underscore 1. So you can import a specific module by writing a code or by writing a statement like from package A import module underscore 1. Now you can necessarily use all the functions that are written in this specific module. So you need not rewrite them again. You can leverage the existing modules that are present in a specific package in order to perform a specific functionality or activity. That's the whole purpose of having package. So before you import a specific package, you need to install the package in your environment. Every project that you work upon, so every single project that you work upon has got an environment associated with it. So we call this as virtual environment. So we always need to create a virtual environment before we begin with any of the projects. Let's say that this is my project called project A. So as part of executing project A, I might require multiple packages. So I simply go about installing all these packages and their specific versions like 1.1.22 and package B probably 2.7.9, so on and so forth. So whatever packages that I'm planning to use in my project called project A, I am going to necessarily install all of them in my virtual environment along with their specific versions. There could be another latest version that's available to package A. I'm still not bothered about it. I'm specifically looking at using the functions or classes that are defined in this specific version 1.1.22 for this package called package A. We'll later understand how we create a virtual environment. Why do we need to create isolated environments like what we are doing now for a specific project? How one isolated environment is different from isolated environments for other projects. So all of this we are extensively going to discuss. We are going to practically understand how we create a virtual environment as well. Okay. But here, what we are trying to understand is we need to install a package into our environment before we import it. So how do you install that package? You install that package by making use of something called package manager. You install the package, you manage the packages. You also manage the different virtual environments that you create. Every project has got its own virtual environment. You need an environment manager. You need an environment manager in order to manage different virtual environments that you must have created. You also would need to have a package manager with which you will be able to install the necessary packages into a specific environment. So you need both environment manager as well as package manager in order to execute your projects. So we are going to understand all of these terminologies more briefly now. Conda is nothing but it's a package manager and an environment manager. So we have pretty much understood what a package manager and what an environment manager is. So Conda here is nothing but it acts as a package manager or an environment manager to you. So it helps you install the necessary packages and their dependencies into your environment. So you can install over 7,500 plus different packages into your environment, all of which using Conda. It's included in all versions of Anaconda and Miniconda. Anaconda and Miniconda that I have listed in other two columns of this matrix are your distributions. So these are distribution softwares which actually helps us install Python along with other necessary libraries or packages that are required for my data science work. So Anaconda as a distribution software is going to help me install Python, which is very much required for us. Conda, which is the package and environment manager, which is also required for us. Along with Python and Conda, it's going to help install and download 250 plus open source scientific packages. I am pretty much not sure if I would require all those 250 plus packages to be downloaded into my machine, At this point, I'm pretty much not sure because it's also occupying large amount of disk space on my machine. 3 GB is quite a lot of disk space. I might not go about installing Anaconda at all, but I might go about installing a bootstrap version of Anaconda, which is Miniconda, wherein it would require a minimal disk space. It might not install all 250 open source scientific packages, but it will only install the ones that are essential and required for us. So whichever are the packages that we repetitively use, only they will be downloaded and installed when you install Miniconda onto your machine. If at all you would want to have any package which is not available from Miniconda, you simply can use Conda package manager to install them into your environment. You always have Conda, which is a package manager with which you can install additional packages. So by default, you will receive a set of essential packages when you install Miniconda. But if you want any of the packages which are not present with Miniconda installation, you can still go about installing it using Conda. So you simply can open up your terminal and key in Conda install the package name. Just writing package name here. The package name could be anything. So this helps us install package into our environment. Let's not worry about how you install package manager, how you install different packages using package manager, how you create virtual environment in the first place. Let's not worry about any of this because we are going to practically understand each one of them in our following sessions. So the objective of this session is only to make you understand what Conda is, what Anaconda and Miniconda distributions are, and what is the exact difference between Anaconda and Miniconda, which one is a preferred method of installing Python and Conda. I would prefer to install Python and Conda using mini Conda distribution, basically because it only provides few essential packages along with Python and Conda. Whereas Anaconda is unnecessarily occupying my disk space by downloading all 250 plus open source scientific packages, which I'm pretty much not sure if I would require all of them to be present in my local machine, right? Cool. I believe we have pretty much understood all of these terms. So in the next session, we are going to practically understand how we download or how we install Anaconda or Miniconda, and then subsequently also create a virtual environment using Conda, which is an environment manager as well, right? So that's all in this particular session. Thanks for watching.